Hi everybody. Until this time I just couldn't decide how to take the video, so we will try to record the video like this. Now it's chapter 3, modeling process quality. What are inside this chapter? Describing variation. What is variation? So what are the things that can be used to describe the variation are stem and leaf plot, histogram, numerical summary of data, the box plot, and probability distributions. Important discrete distributions, as you maybe remember from statistics course, the hypergeometric distribution, the binomial distribution, the Poisson distribution, the negative binomial, and geometric distributions. Important continuous distributions are normal distribution, log normal distribution, exponential distribution, gamma distribution, Weibull distribution. Probability plots, normal probability plots, and other probability plots. And useful approximations we need to use for quality are binomial approximation of the hypergeometric, the Poisson approximation to the binomial, and the normal approximation to the binomial. So from each distribution we go on to the other distribution with some limitations. For example, n higher than this, or p value, which is the defective proportion, is less than 0.05. kinds of limitations will let us move from one distribution to another distribution. So let's go on to the chapters. These are the learning objectives. So we start with describing the variation, and the first graph we would like to draw is the stem and leaf diagram. How do we draw that diagram? There's an example here. There are 40 claims. Each day people are recording the employee health insurance claims. How many days do they claim? For example, the first claim says 48 days to pay for the employee for their health. Second claim is 41 days. So company is paying money for the number of days to the employee because of the health problems the employee has. So as you can see, there are numbers like 48, 41, 35, 36. In order for us to draw the stem and leaf diagram, we need to put the numbers into order. For example, let's close look at the numbers, the values. What is the least number that we come across with? Let's look at the values. I see here 26. Anything less than 26? Yes, there's 17. Anything less than 17? Yes, there's 16. So 16 is the least value here. What is the most value? The highest value. Let's look at it again. 48 we have, and then we have 56, and we don't see anything higher than 56. So we will arrange the numbers in from least to the most values. After we arrange them, on the right we see the stem and leaf diagram. So we write the 10th digit as the stem and the first digit as the leaf of what we have. For example, we had 16, so we write 1 here and the 6 here, so we symbolize it as we have only 1 16. We have 7 7 means that we have 17 and 17, so if we have two 17s, let's look at here. There's 17 here, and there was another 17 here. So there are two 17s. After that, we have 22. So When we put them in order, when we put the numbers in order, then we see that we have, for example, 3 22s. So in order for us to read stem and leaf diagram or draw stem and leaf diagram, we take the 10th digit as the stem and the first digit as the leaf. So since we have 3 2s on the row of 2, it means that 22, 22, 22 is repeated 3 times. So after we finish in a diagram, the stem and leaf diagram, we try to see some kind of a pattern looks like a normal diagram like this. In our example, it's some kind of fits with the normal diagram. So we would like to see the variation of the numbers by plotting the stem and leaf diagram. The other tool that we can use is plot of data in time order. So first claim 48 days, second claim 41 days. So we plot each of them one by one in order of claims. And after plotting them, you see here as the row, we add the plots. So this may look like a normal diagram at the same time. Why do we plot these, or why do we just draw stem and leaf diagrams? We would like to find a pattern for the numbers, for the data we have in our hands. So another useful tool is histograms. So histograms gives us some idea about the distribution also, the variation also. So this again, this data looks like normal distribution. So they use the Minitab histogram. Additional Minitab graphs can be in figure 3.5. There is an histogram, as we all know, but in figure 3.5 they drew the cumulative frequency plot of the data. Now, how do we draw the cumulative frequency plot? We just add these values in the first graph. We add these values to each other one by one until they end up to 100. So we can see how the data is increasing from least value to the most value. This is an example. So, how do we measure the variability with the numerical summary of data? X bar, the average, is calculated by adding all the numbers. X1 plus X2 goes to Xn divided by n. So we take the average like this. There was an example here. So there were 100 data. They divided all the values, added values, divided by 100 to find the average there. So that was an example. And the variability in the sample data is measured by the sample variance. Sample variance is different from the population variance in calculation. Just I would like to take attention to the denominator, which is n-1. In the population, you divide what you have as the numerator to big N. So all the population, it can be 10,000, 100,000, but when we take a sample, when we take the sample variance and calculate it, we divide by n-1. Now why? To explain this, I need to draw some things for you.